Welcome to Ask and Learn.
Hi everyone, so what we have here is a rod that's rotating about an axis at theta dot equal to 4 radians per second. And we also have a collar that's of mass 0.5 kilograms. And the motion of the collar is described as r is equal to 1.6 cosine of theta. What we're asked to solve for is the force that the circular rod exerts on the collars and the force that the rod exerts on the other collar when theta is equal to 45 degrees. So what we're going to go ahead and do is apply our knowledge in normal, tangential, and rotational motion and draw a free body diagram and incorporate that and apply Newton's second law and F equals ma to solve for these forces. So let's go ahead and do that. So what we can do first is we know that r is equal to 1.6 cos theta. So we know that r dot is equal to negative 1.6 sine theta times theta dot. And that r double dot is equal to negative 1.6 cos theta times theta dot squared minus 1.6 sine theta times theta double dot. So we know that at theta equal to 45 degrees, theta dot is equal to 4 radians per second, and that's constant, so theta double dot is equal to 0. Therefore, we can conclude that r is equal to 1.1314 meters at 30 degrees of theta. R dot is equal to negative 4.53 meters per second. And r double dot is equal to negative 18.102 meters per second squared. Then we can calculate AR, or the acceleration in the radial direction. That's equal to r double dot minus r theta dot squared. And that's equal to negative 36.2 meters per second squared. And then we can calculate A theta, and that's equal to r, clear this, is equal to r theta dot plus 2 r dot theta dot, which is equal to negative 36.2 meters per second squared as well. Next, we can draw a free body diagram of the collar. So here are our collars. Here is our theta direction, and here's our r direction. And we have a couple of forces acting on this. Here we have the force from the rod. We're going to call that FOA. And here we have the normal force, and we also have the weight force. And this angle right here is theta equal to 45 degrees. So we can resolve our forces in the r and theta direction. We see that the net force in r is equal to m times AR. And resolving forces in the r direction gives us negative n cos 45 minus mg cosine 45 is equal to m times AR. And we can go ahead and isolate n here, and this gives us an n that's equal to 20.7 newtons. Next, what we can do is we can do our Newton's second law in the r direction, in the theta direction, excuse me, and that's equal to m times a theta. And this gives us that FOA minus n sine 45 minus mg sine 45 is equal to m times a theta. And actually this results in that FOA is in fact equal to 0 newtons. So that's one final answer, and here's our other final answer.